In the last section, we looked at light as a wave, and it had wave-like characteristics of frequency and wavelength. This time we're going to look at wave as a particle, and a particle that has energy. Planck was a German physicist who studied the quantization of that energy. By looking at the temperature and the light of hot objects, specifically metals, he found an equation to equate that energy with both the wavelength and frequency. And this video is going to kind of show you.
We're going to do a flame test on a number of selected compounds, primarily group 1 and 2 ions. And these are aqueous solutions, and we have just a inert metal loop. We're going to dip the end into the solution and put it into the flame. And that excitation characteristic color is like a fingerprint for an element. So we're going to look at a number, and then we're going to ask you to identify some unknowns. Potassium. It should be a lavender color. This is barium. It's a green. This is calcium. Calcium. Sort of a yellow-red. Strontium. This one's a pretty red one. Lithium. Sodium is a bright yellow. And the last one is copper. And this is the most vivid of all of them.
So this is basically what they do to make fireworks. If you want a firework that's green in color, you inside the gunpowder material or ignition material, you basically add a salt of copper and you get that green color, or a potassium salt and get that violet color of potassium, or orange would be probably sodium. So those are the effects that we're talking about. Now, the equation that Planck came up with was E is equal to NhV, and N is simply the quantum number, so basically it's the number of photons that we're going to be talking about. And Planck's constant, H, is 6.63 times 10 to the minus 4. Sometimes you'll see this taken out to 4 decimal places of 6.626. So a lot of times you'll see this as written as 6.626. Of course it does. Times 10 to the minus 34th, and it's joules per second. Okay, I just rounded to 3 significant figures myself. Okay, and so it's a physical constant relating the frequency and the energy. Now we're going to assume that n is 1, and so by getting rid of n, it becomes E is just h nu, and again nu is the frequency. So the first problem asks, what is the energy associated with a 7.66 times 10 to the 14th hertz wave? Well, hertz is a unit of what? Because you have to be able to identify that to be able to do the problem. So hertz is a unit of frequency. So that means nu is 7.66 times 10 to the 14th, Hz. It wants to know what the energy is. Energy is symbolized by a capital E and a question mark. So you're looking for the equation that relates E and nu. So the equation is E is equal to h nu. We want to remember that h is that constant, 6.63 times 10 to the minus 34th joule seconds. And so the energy is going to be 6.63 times 10 to the negative 34 times 7.66 times 10 to the 14th. This is per seconds, that's joule seconds, so I just end up with joules, and I get 5.08 times 10 to the minus 19th joules. So one photon of energy does not have a lot of energy. This is actually a very, very, very small number here. Okay. Next problem is now it wants to know what is the frequency. So nu is what I want to know. If I have a wave carrying 8.35 times 10 to the minus 18th joules of energy. So it identifies that joule is energy, but you need to remember that. We did that in chapter 6. Okay, so I have 8.35 times 10 to the minus 18th joules. So again, the equation that relates these two is E is equal to h nu. H is a constant, so it's going to be the same thing for all of them, 6.63 times 10 to the minus 34th. And like I said, it's joule seconds. Okay. So I have 8.35 times 10 to the minus 18th is 6.63 times 10 to the minus 34th times nu. I want to divide both sides by the 6.63, so I have 8.35 times 10 to the minus 18th divided by 6.63 times 10 to the minus 34th is equal to nu. You want to make sure that you actually enter this into your calculator because of the fact that you want to go back to chapter 1 when we were dividing by a times 10 power. And when I do this, I get 1.26 nu is 1.26 times 10 to the positive 16th. And the units for frequency can be hertz. You can also write this as 1.26 times 10 to the 16th per second, or the other way is 1.26 times 10 to the 16th seconds to negative 1. So you'll see these units written in all three ways there. But I highly suggest that you take time and put this into the calculator, and you'll get the 1.26, but make sure that on your calculator you get a positive 16. If you don't get a positive 16, instead you get a negative number, that means that you have not entered this correctly. And so you need to go back to chapter 1 and look about how to enter that into your calculator. We're going to stop here. In the next video, I'm going to have more problems like this.